Welcome. In our earlier video on DNS, we provided an introduction to this service and explained some of the organization of the system. We noted that there were two types of DNS queries, a recursive query and an iterative query. We noted also that the services provided by DNS were essentially transparent to users of the network application. The applications themselves made the calls to what we called the resolver to request a name resolution, and in return received an IP address from the DNS system. In this video, we're going to see a little bit about what goes on inside the DNS system by invoking some of its lookup services through a special utility called nslookup. Not surprisingly, DNS is one of the most important applications on the network. A DNS failure will prevent hosts from locating one another using host names. Now, when people refer to hosts or host names, they use mnemonics such as www.google.com or www.amazon.com and so on. But on the internet, a host is actually identified by an IP address. So applications need to provide the address of the host when they send packets to one another. The reason for this, in part, is due to the fact that the host names provide very little, if any, information about the location within the internet of the host. Even when the host name includes something like a country code, as in rackspace.co.uk, this simply tells that the host is probably somewhere in the United Kingdom. Now, while people prefer the mnemonic identifier, network core devices, such as a router, prefer the IP address. So one of the services provided by DNS is to convert the symbolic host names to the IP addresses. But DNS can do other things. It can also be used to transfer information between DNS servers, to identify the host name associated with an IP address, kind of the reverse of what we just mentioned, an inverse or pointer query. It can also be used to look up other name elements, such as the mail exchange record. Note that DNS is commonly used by other application layer protocols, such as HTTP and SMTP, and the purpose is to translate the user-supplied host name to an IP address. In this video, we're going to examine a utility called nslookup. This utility is used in one way by network administrators or users of a network to obtain information about DNS records. So nslookup is really a network administration command line tool that can be used to query the DNS to obtain the mapping between a domain name and an IP address, or some of the other DNS records that we've suggested. nslookup can be run in two modes, what we call interactive mode and another mode called non-interactive mode. There are versions of nslookup available on a variety of operating systems. It's available on Windows and Unix systems, and we'll be demonstrating its behavior through some queries that were run using a Windows system. To access nslookup, you first begin by opening a command window. Because nslookup is a command line or textual program, as opposed to a graphical program, it's invoked from the command prompt rather than through some kind of a graphical interface. And when you run this utility in a non-interactive mode, it's useful when you have a single query you wish to have answered. But the interactive mode is more beneficial if you have a series of questions, carry on, in a sense, kind of a dialogue with the utility. Here's an example of running nslookup in an interactive mode. From the operating system command prompt, you would enter nslookup simply without any parameters, and this brings you into interactive mode. The transition occurs from the operating system prompt to the nslookup interactive prompt. When you begin the application, the current default server is indicated. This gives the name and the IP address of the server. Now, before we go any further, let me show you a very important command. If you start nslookup, eventually you're going to want to stop it. The exit command instructs nslookup to terminate its execution and return control to the operating system. Upon completion, we are still within the command window, but now we see the operating system command prompt. In our earlier video on DNS, we mentioned various types of DNS resource records. We're going to take a look at a few of these now. Now, after nslookup has started in interactive mode, we can enter the name of a host at the nslookup prompt. This is going to cause nslookup to obtain information about this host. By default, it's going to obtain the type A, an IP version 4 address. In the next example, we make this request explicit. So at the startup in non-interactive mode, we specify the type is equal to A, specify the name that we want to have resolved. And what gets returned for us is the IP address for that name. Observation here is that the answer is said to be non-authoritative. This means it didn't go to an authoritative server. There's also something called a reverse lookup. And in this case, what we're doing is providing an IP address, and what is returned to us is the name that maps to that IP address, kind of the opposite of the type equal A request that we just submitted. Now, a DNS pointer record, or PTR for short, provides the domain name associated with an IP address. And it's this type of record that is used in a reverse DNS lookup. It's also possible to use a name server other than our default. So this example is showing in a non-interactive mode how we can request a lookup for bbc.co.uk. And what we want to use is this server that has an address of 8.8.8.8. This is the Google public DNS, and we're specifying use that server rather than our default server. It performs the lookup for us and returns the addresses associated with this name. Note again that this is still not an authoritative server. As an alternative to the non-interactive mode, we can also specify that we want a name resolved using a different server, and specify, as we see here from the nslookup prompt, the name and the server to be used. One other possibility is to actually change the server that's going to be used for our run of nslookup. So when we start nslookup, we execute what's called the server command and specify the name server that we wish to use for subsequent name resolution requests. In this case, this server will stay in effect for all of the commands that follow until we either specify a different server to be used or we terminate nslookup. And then the next time, by default, we'll come back to our default server. We've indicated that DNS has a variety of resource records. To request one of these other types of resource records, we can use type or query type. In our first example, we specify a specific type of mail server, MX, by starting nslookup in non-interactive mode and providing query type equals MX, followed by the name of the domain we'd like to look up. The second example shows us how to accomplish this task in interactive mode. So we start nslookup, and then we're given the nslookup prompt, and from that we set the type equals to MX and provide the name. The third example on this slide is looking for the name server. And we're specifying the query type as NS, indicating we're interested in the name server for our BBC domain. Another option we have is to specify a type of SOA, and this informs nslookup that we're interested in finding the authoritative name server, or what would be considered the primary name server for our specified domain. So here in non-interactive mode, we specify type equals SOA, and we specify our BBC CO UK. What is returned here is a line that says primary name server equals NS BBC CO UK. So this is the DNS authority for the domain that we specified. If we include the authoritative name server to an address query, that is a type equals A, the record that will be returned is actually going to be an authoritative record. It's coming from that particular name server. One other thing to point out before we move beyond this slide is toward the bottom, what we have is a line that says default TTL equals 900, which is 15 minutes. We'll talk a little bit more about this in just a moment when we get back into the discussion of caching. Now, we found our name server for the BBC domain, and in this case, we're performing a request to get the address for BBC CO UK, and we specify that we wish to use that name server, the authoritative name server that we just discovered a moment ago. The output doesn't look much different than what we've seen before. There is a difference, however, and that is it does not say that this is a non-authoritative server. So the absence of that disclaimer that says non-authoritative server tells us that this is the official source. This is the authoritative server's information. So this is official. A DNS cache, sometimes called a DNS resolver cache, is a temporary database maintained by a computer's operating system that contains records of all the recent visits and attempted visits to websites and other internet domains. So DNS uses caching, which reduces the load on authoritative name servers, but means that sometimes records can become out of date. To see how long a record is cached, we can include the debug option, as shown in our current example here. Running this request with nslookup produces a great deal of output. So I emphasize that the output presented here is just a very small excerpt. It is significantly truncated. But the questions section shows that the request was for A records for this domain of Rackspace. So it's a type A record. The answers that come back tell us the IP address and also gives us the TTL, the time to live. The TTL in this case is 279 seconds. That's 4 minutes and 39 seconds. If we were to query this again and assume that it has not been updated, this number is going to get smaller and smaller. At some point, the value of the time to live is going to make the value that we have in the cache kind of questionable, and the system will discard it, and as a result, the next time a query comes for Rackspace, we would have to perform additional work to get a fresh and accurate value of the address record. In one of the earlier slides, I brought to your attention a TTL that was listed, and this was indicated as the default TTL. So what we're seeing in this example is this may have had a default of, say, 5 minutes, but by the time we got this information, 21 seconds had already elapsed, so it was already starting to age. In the case of the example that I showed you a couple slides earlier, it showed a default of 15 minutes. This would be, if you immediately received it, it would be good for 15 minutes, but a countdown would begin. And again, the TTL would get progressively smaller. Anyway, the debug option provides a way of gaining some insight into this information. Well, we briefly examined nslookup, an interesting utility that allows us to explore some of the information stored in the domain name system, a DNS. So we're able to access various resource records and ask questions of the system. So hopefully this gives you a better feel for how DNS operates, because much of what we explored with nslookup is kind of transparent when we run an application. The application simply issues a request to the local name server, and the local name server comes back and said, here's the IP address. But there's a great deal of additional information available in DNS. And now we have a little bit more insight, hopefully, in terms of what kind of information and how to access that. Well, this concludes our two-part series on DNS.